Another type of statistical testing we're going to look into is called the t-test, or more specifically, the two-sample t-test. Again, we're going to follow roughly the same procedure as the others, but the t-test has different properties. So one of the main ones is that it's used for data that are measuring the same thing. So you can't look at like GPA and height. Both data sets that you have, both tables that we're going to test, have to have the same measurement. So they both have to have measured distance, or they both have to have measured time, and so on. Another thing is that it only applies to normally distributed data. We can use the GDC to calculate the final value, just as we've been doing with the others. It's mainly, you'll notice that we do it with 5% significance level, but we can do it with others like 1% and 10%. Now, the hypothesis for the t-test is slightly different. So the way we structure it is we use the mean of the two data to describe the hypothesis. So what we're going to do, the calculator will do for you, but what you will have to do is take the mean of the first data set. We're going to call this xi and then a bar on top, and the mean of the second data set, which we're going to call x2 with a bar on the top. And what the null hypothesis wants to claim is that there's no difference between the two datas, which means that the first mean, the mean of the first data set will be equal to the mean of the second data set. So your null hypothesis is always that there's no difference, therefore the means will be equal. Now, alternative is slightly more complicated, and it will depend on the question that you have. So you have to read the question and understand what they want. But if the question says, oh, we want to see if there's no difference between them, that's it, that's what they want to see, then the alternative will be a two-tailed test, which is that they are not equal. Now, if they want something like, one data set is more than the other or less than the other, then you need to use what we call the one-tailed test. So the alternative will depend on whether you want just to test whether they're equal or not equal, or whether you want to test that one is more than the other. But the null hypothesis is always the same, that they are equal, the mean. So we're always talking about the mean. So let me give an example just to know what the hypothesis will be. So in this example, if you read through it, Mr. Arthur gives two chemistry groups the same test. He wants to find out whether there's a difference between the achievement level of the two groups. So we're not talking about more, we're not talking about less. We just want to see if there's a difference between them. So the wording here means that either they're the same or not the same, which means that the null will be that there's no difference. So the first mean equals second mean. And the alternative will be that there is a difference. So you're going to say that they're not equal. And that's what you want to test. So that's because the question just said they want to see if there's a difference between them. In this question, if you pause and read through it, it says that the company claims that they developed a fuel that will increase the distance traveled for every liter of oil. So we have the new fuel for the company, and they're claiming that this new fuel has a higher distance traveled than the original fuel. So it means that the second mean has to be higher than the first mean. So we're looking at a one-tailed, and we're looking at the fact that the second mean is higher. So if you notice in the previous slide, the one-tailed, you have two versions. Either the first mean is less or it's more. Or the second mean is less and more. And in this case, the second question, we want to see that the new fuel, which is the second mean, is more than the original, because the numbers here are the distance traveled. So again, the null will be no difference in the mean, so they're equal. And the alternative is that there is a difference. The new fuel has a better travel distance. So the mean x2 has to be greater than x1, or the first mean is less than the second mean. Now, if I'm going to actually use this example, the oil example, we're going to go through a full t-test here. So it's a one-tailed one. We already discussed that the means are going to be equal, and we have a one-tailed test here where the second mean is bigger than the first mean. And then we have our given or observed value table. In t-test, you don't have to do the expected value table, and you don't have to do a degree of freedom, so it saves you a bit of time. what you're going to do is in the calculator, you're going to enter your data in the two lists. So I already did that. I went to Stat Edit and I put all my data in there. And then I'm going to go to Stats and then I'm going to click on Two Sample T-Test. Be careful. Do not pick the T-Test because the second option, because that's not what you want. You want a two sample T-Test. And once you're there, you're going to get this already filled in. But you need to make sure that the input is set on data, that you have the correct L1 and L2 set there. Make sure your frequency is equal to 1 in each case. And then the mu1, if you notice on the 6th line, this is where you pick your alternative hypothesis. So this is where the alternative hypothesis is. And if it's the two-tailed, so you want to say they're not equal, then you pick the first one. If you want to say that the second mean, so that mu2 represents the second mean. So you want to say that the second mean is greater, and that's what we want for this example. We want the second mean to be greater. The third option is that the second mean is less than it. So again, if you focus on the 6th line, you have three options, whether they're not equal, whether the second mean is greater or the second mean is less. So again, depends on setting up your alternative hypothesis correctly. For our example, we want the new fuel to have a higher distance traveled, so we're going to pick the second mean to be greater than. And then for the pooled option, just select yes and then go to calculate. You're going to have these results, and again, double check that your alternative hypothesis is correct. It shows it above, and you're going to just pick out the t value and the p value. So these are the values you should conclude with. So when the question tells you conduct a t value test and a p value test, then you just select those that negative 2.83 and the 0.00561. Now, using this in an exam, we're just going to use the significance level and the p-value to conclude our test. So it's not like the chi-square test where we had another option, but the conclusion is still the same as the other test. So we have p-value versus significance level, and we can notice that the p-value is less than our significance level, and the significance level is always given in the question. And therefore, using the right side of the table, we can see that we reject the null and accept the alternative hypothesis. Therefore, the company's new fuel increases distance traveled, hence their claim is true. So make sure you always go back to the question, link it back to the question, and understand what it wants. The only tricky part of the t-test is to make sure that you select the correct alternative hypothesis. And that mainly comes from reading the question carefully and making sure that you underline the important points and so on. And then making sure you select the correct option in the calculator. Otherwise, the rest of the test is quite easy to conduct. You can also conduct the test if the data sets are not equal. So you could have that the first list has this many values and the second list has 3 more values, for example. It's fine if the lists are not equal. That's completely okay.